Dear friends, in this episode, we are going to discuss metals and non-metals. This podcast is brought to you by chemistrynotesinfo.com. Let's start it. What is metals? Metals are the solids, materials which are typically hard, malleable, ductile, and conduct heat and electricity, and also possess metallic luster. Example: iron, gold, aluminium, silver, copper, etc. Non-metals. Non-metals are chemical elements which lacks metallic properties. Non-metals are either solid or gases, except bromine, which occurs as liquid. Non-metals vaporize easily, insulator of heat and electricity. Non-metals have high ionization energy and electronegativity values. Example: hydrogen, helium, nitrogen, oxygen, fluorine, neon, chlorine, argon, krypton, xenon, radon, bromine, carbon, phosphorus, sulfur, etc. Exception in metals and non-metals. Mercury is liquid at room temperature while other metals are solid. Gallium and cesium have very low melting point while other metals have very high melting points. Iodine is non-metal but it has luster, means it is shiny. Carbon, non-metal, exists in different forms and these forms are known as allotrope. Graphite, allotrope of carbon, conduct electricity, and diamond, allotrope of carbon, have very high melting point and boiling point. Is hardest natural substance known. Burning of metals in air. These are the some chemical properties of metal. One of them is burning of metals in air. Metals burn in air as oxygen present in air to produce metal oxide. So reaction occurs as follow: metal plus oxygen gives metal oxide. Example: copper plus oxygen gives copper oxide. Aluminium plus oxygen gives aluminium oxide. Mostly metal oxides are basic in nature, but some metal oxides are allotrophic in nature. That is, they show acidic as well as basic behavior like aluminium oxide, zinc oxide. Mostly metal oxides do not dissolve in water, but some dissolve to form alkali. Some metal prevent further corrosion by making protective oxide layers on itself like aluminium, zinc, lead, etc. Some metals like sodium, potassium catches accidental fire, so to prevent it they are kept fully immersed in kerosene oil. Reaction of metals with water. Most metal react with water to form metal oxide and hydrogen gas. Reaction occurs as follows: metal plus water gives metal oxide plus hydrogen gas. Example: potassium plus water gives potassium oxide plus hydrogen gas. Not all, but some metal oxides react further with water to give metal hydroxide. That is, potassium oxide plus water gives potassium hydroxide. Some metal do not react with water like copper, lead, silver and gold. Reaction of metal with acids. Most metal react with acids to produce salt and hydrogen gas. Metal plus dilute acid gives salt plus hydrogen gas. Reaction occurs as follows: 2Al plus 6HCl gives 2AlCl3 plus 3H2O. As HNO3 is a strong oxidizing agent, so hydrogen gas not evolve when reaction takes place between metal and nitric acid, because HNO3 reduces itself to nitrogen oxide. Aquaregia, royal water, is freshly prepared mixture of concentrated hydrochloric acid, that is concentrated HCl, and concentrated nitric acid, that is concentrated HNO3, in the ratio of 3:1. Aquaregia have great dissolving power, highly corrosive fuming liquid. Aquaregia have ability to dissolve gold and platinum also. Reaction of metals with solution of other metal salts. More reactive metal have ability to displace less reactive metal from their compound in molten or solution form. For example, if metal A is more reactive than metal B, then it displaces metal B from solution of metal B. Reaction occurs as metal A plus salt solution of B gives salt solution of A and metal B. Example as follows: Fe in solid form plus CuSO4 in aqueous forms gives FeSO4 in aqueous form plus copper in solid form. Reactivity series of metals. Reactivity series is the series in which metals are arranged as per order of decreasing activity. This activity series is developed after performing so many displacement experiments. This series is also called as activity series. So, elements arranged in the order of decreasing power of activity. So, first metal is potassium, that is the most reactive, then sodium, then calcium, then magnesium, then aluminium, then zinc, then iron, then lead, then hydrogen, then copper, then mercury, then silver, then gold. Gold is least reactive. Now question is, how metals react with non-metals? As we know, every element has tendency to achieve completely filled valence cell to get electronic configuration of nearby noble gas. For example, a metal, say sodium, react with non-metal chlorine to get complete valence cell. So Na lose one electron from its outermost shell, which is taken up by chlorine. As a result, they both have completely filled valence shell. In this process, sodium becomes positively charged and chlorine becomes negatively charged, and these charges attract each other to form NaCl. So Na have configuration of 281 and it loses one electron to achieve Na plus and configuration of 28, whereas Na plus is sodium cation. Similarly, Cl have configuration of 287. It gets one electron to achieve Cl minus. Cl minus is chlorine anion, formation of sodium chloride. Na plus plus Cl minus attract towards each other to form NaCl. Properties of ionic compound. Ionic compound also called electrovalent compounds, and their properties are described below. Dear friends, you are listening this podcast at www.chemistrynoteinfo.com podcast portal. You can visit our website www.chemistrynoteinfo.com to learn and to get PDF notes and so many chemistry contents also. So we are discussing properties of ionic compounds. First property is physical nature of ionic compounds. Ionic compounds are solid and hard due to strong force of attraction between positive and negative ions. Ionic compounds are also brittle. Melting and boiling point of ionic compounds. Ionic compounds have high melting and boiling points as large amount of energy is needed to break ionic bonds. Solubility of ionic compounds. Ionic compounds are soluble in polar solvents like water and insoluble in nonpolar solvent like ether, kerosene, etc. Electric conductivity of ionic compounds. Ionic compounds conduct electricity in aqueous and molten state as ions move freely but do not conduct electricity in solid state. Occurrence of metals. Maximum metals occur in Earth's crust and some metals occur in seawater. Metals and its compounds exist as minerals, and if the percentage of metals in minerals are large, then they are known as ores. Extraction of metals. Reactivity series is very helpful in metals extraction, as metals present at the bottom of reactivity series are least reactive, so found in free state, like gold, silver, and platinum found in free state. Metal at top is most reactive, and metals in the middle are also reactive, so found in combined form. Metals generally found as oxides, sulfides, carbonates on Earth's crust. Steps involved in extraction of metals from ores. Ore is processed to get concentration of ore. Then metals of high reactivity, then electrolysis of molten ore, then we get pure metal. Metals of medium reactivity are extracted by carbonate ore, by calcination, or sulfide ore by roasting. Then we get oxide of metals, then we do reduction to metal, then purification of metal. Metals of low reactivity, sulfide ores by roasting, then metal, then refining. Enrichment of ore, the process of removal of impurities or gangue from ore before extraction of metal is known as enrichment of ore. Gangue is terminology used for impurities like sand, soil, etc. present in ore. Extracting metal low in reactivity series or activity series. Metals present at bottom or low position in activity series are very unreactive and can be obtained in pure form or pure metallic form by just heating alone. Example: cinnabar HGS, ore of mercury Hg. So reaction occurs as 2HGS plus 3O2 plus heat gives 2HGO plus 2SO2. Then 2HGO plus heat 2Hg plus O2. Similarly, Cu2S, ore of copper, 2Cu2S plus 3O2 plus heat 2Cu2O plus 2SO2, 2SO, 2Cu2O plus Cu2S plus heat 6Cu plus SO2. Extracting metals in middle of activity series. Metals in middle like iron, zinc, lead, etc. are moderately reactive and present as sulfides or carbonates. Metals can be easily extracted from its oxide, so sulfides and carbonates are reduced to oxides. Then these metals oxides are reduced to corresponding metal by using suitable reducing agent like carbon. These podcasts brought to you by chemistrynotesinfo.com. Roasting. Roasting is a process of converting sulfide ores into oxides by heating strongly in the presence of excess air. 2ZnS plus 3O2 plus heat gives 2ZnO plus 2SO2. Calcination. Calcination is a process of converting carbonate ores into oxides by heating strongly in the presence of limited air. Reaction occurs as ZnCO3 plus heat gives ZnO plus CO2. Oxide reduction. Oxides of ores are reduced to metal by using suitable reducing agent like carbon or highly reactive metals. ZnO plus carbon gives Zn plus CO. 3MnO2 plus aluminium gives 3Mn plus Al2O3 plus heat. Extracting metals at top of activity series. Metals present at top in activity series are very reactive and they are not obtained by heating their compounds with carbon. For example, sodium, calcium, magnesium, aluminium, etc. cannot be obtained by reducing with carbon as these metals have more affinity for oxygen than carbon. So these metals are obtained by electrolytic reduction. In electrolytic reduction, the metals get deposited at cathode, that is positive electrode, and gas like chlorine gets liberated at anode, that is positive electrode. Reaction for molten sodium chloride at cathode, Na plus electron gives Na, at anode 2Cl minus gives Cl2 plus 2 electron. Refining of metals. Refining of metals are done to obtain metals in very pure form by removing impurities present in it. Electrolytic refining is widely used method for this purpose. Electrolytic refining. Electrolytic refining is the method of obtaining very pure metals from impure metal. Metals like copper, zinc, nickel, silver, tin, gold, etc. are refined electrolytically. In electrolytic refining, anode, that is positive electrode, is made from impure metal and cathode, that is negative electrode, is made from thin strip of pure metal. Metal salt solution works as an electrolyte. When we applied electricity or electric current across the electrodes, then current starts flow through electrolytic solution. Pure metal comes out from anode and dissolve in electrolyte. An equivalent amount that is to that comes from anode. of this pure metal from electrolyte solution get deposited on cathode. In simple way, we can say that pure metal comes from anode and get deposited on cathode by using electrolytic solution and electric current. Insoluble impurities settle down below anode at bottom and we say it as anode mud, while soluble impurities mix in electrolyte. Corrosion. Natural process of conversion of refined metal to its high stable form like oxides or hydroxides of metals is known as corrosion. Corrosion is the process of gradual destruction of any material like metals by environment and chemical reaction. Example, rusting of iron. Prevention of corrosion. There are so many methods to prevent corrosion like applied coating, anodization, galvanization. First we learn applied coating. Applied coating is surface treatment method. Planting, enamel application and painting are applied coating method to prevent corrosion. These methods create barrier between metal and environment. Anodization. It is anode surface treatment process in which we made thicker oxide layer at metal surface. Galvanization. Galvanization is the process of coating steel and iron with very thin layer of zinc to protect them from rusting. Overall, painting, greasing, oiling, chrome plant plating, galvanizing, alloy making, anodizing are some ways for the prevention of corrosion. Thank you to listening this episode. This episode is brought to you by www.chemistrynotesinfo.com.